We're going to spend the day today looking at the second derivative using implicit differentiation. Remember, second derivative is going to talk about the acceleration of a function or of a relationship between x and y. So a couple of things that we want to remember to do as we come up with the second derivative. One, we want to be able to find the first derivative. Remember, when we take the derivative of y, we'll put that dy dx, and that's what we're going to solve for. To find the second derivative, we find the derivative of the first, but we're also going to replace a dy dx as needed. And we'll see that come up here very shortly as we look into our first example. So the first example here is asking us to find the second derivative of x squared plus y squared equals 16. That daggone blasted circle again, huh? So we're going to go ahead and find derivative of our circle. If you don't remember, we get 2x plus 2y dy dx is going to equal 0. So dy dx will equal a negative x over y. I don't know how many times we've done that, but there's one more time, isn't it? Hopefully you got it now. Now we're going to find our second derivative. So to denote the second derivative, we're going to take the second derivative of y with respect to x. Notice we're squaring that d on the first one, we're squaring the x on the second one. It's not a misprint, that's our notation. So second derivative of y with respect to x. To find the derivative of negative x over y, what we're going to do is we're going to use our quotient rule. So we have y times negative 1 minus negative x times the derivative of y, which is dy dx, divided by the denominator squared, or y squared. We're going to go ahead and clean this up just a little bit as we're looking at it. So we get negative y plus x dy dx. We know something about dy dx. That's the change in y, or the change in x, or the derivative of y with respect to x. Well, look, that's negative x over y, isn't it? So we can go ahead and replace that with a negative x over y. And that's going to be over our denominator squared, our y squared. We can go ahead and clean this up. So we get negative y plus, actually it's going to be a minus sign, isn't it? X times a negative. So we get x squared over y squared. We can go ahead and find a common denominator for the numerator. We're not going to leave it as the fraction within a fraction, are we? You thought so. So x squared over y squared. This is over 1. So we can multiply by the reciprocal, which is 1 over y squared. So cleaning this up, we get the negative y squared minus x squared over y times y squared, or y to the third. And that gives us our second derivative of our circle. Remember, second derivative is also talking about the acceleration. I have one last example, so kind of a short day here. We're going to practice a lot. Second derivative here, well, the first thing we're going to do is find our first derivative. First derivative, we're going to implicitly derive. We get 1/2 x to the negative 1/2. To that, the derivative of y to the 1/2, which is 1/2 y to the negative 1/2 dy dx. And that's going to equal the derivative of 3, which is 0. Go ahead and solve for dy dx. So we're going to subtract our 1/2 x to the negative 1/2 and divide by 1/2 y to the negative 1/2. So I'll go ahead and kind of step that out for us. We get negative 1/2 x to the negative 1/2 divided by 1/2 y to the negative 1/2. That looks ugly. What I would definitely do is suggest that we clean this up. So we should see that 1/2 will cancel. 1/2 divided by 1/2 is 1. Negative exponents we can make positive. If they're in the numerator, we can move them to the denominator. Denominators come up to the numerator. So we get a negative of y to the 1/2 over x to the 1/2. And that's going to be my derivative. Now we can go ahead and play with the second derivative. Second derivative, again my notation, d squared y over dx squared, tells us we have the second derivative. We're going to have a quotient rule again. This negative, we can either put that negative with the numerator, the denominator, or just kind of leave it out there on the outside. I like to just kind of leave it on the outside personally. And we'll play with that later if we need to. So derivative, we have quotient rule, low, or our denominator times the derivative of the numerator. So we get 1/2 y to the negative 1/2 From that, we're going to subtract our y to the 1/2, our high d low, which is going to be 1/2 x to the negative 1/2. Oh, I forgot my dy dx. Remember the dy dx when you take the derivative of y. So that's going to be over our denominator squared, so x to the 1/2 squared. Now we can go ahead and clean this up just a little bit. So we have the negative out there. We have a negative exponent that's going to go to the denominator of its term, so only of this first part here. We can't take it all the way to the bottom because it's a minus sign up here in the numerator. So we're going to take that y to the negative 1/2 to the bottom of its term, which there's already a 2 down there. So we're going to get x to the 1/2 dy dx divided by 2y to the 1/2. From that, we're going to subtract. Again, we're going to take this x to the negative 1/2, make it a positive exponent, taking it to the denominator of its term. So we have a y to the 1/2 in the top numerator and a 2x to the 1/2 in our denominator. And that's going to be over x to the 1/2 squared. We're going to multiply those exponents and end up with just an x. Now what I want to do is get rid of this dy dx. I know that dy dx equals negative y to the 1/2 over x to the 1/2. So we have x to the 1/2 times the negative of y to the 1/2 over x to the 1/2, which is going to be kind of nice, isn't it? Anybody notice something that's going to happen there? I'll give you a second to ponder. We ponder a lot of things, but that's something else you can ponder. Alright, so hopefully you saw that the x to the 1/2 will cancel each other out. So we're left with negative y to the 1/2 over 2y to the 1/2. So the y to the 1/2 will cancel as well. So we have the negative of, well, this kind of looks nasty up here, but we just have a negative 1 up there over 2. Oh, that's over a 2. Minus y to the 1/2 over 2x to the 1/2 all over x. Now we can go ahead and find a common denominator for that numerator. Common denominator is going to be 2x to the 1/2. So our negative 1 is going to get an x to the 1/2. So we have x to the 1/2 minus y to the 1/2 over our 2x to the 1/2 over x. And it's all of the negative of that. Almost done. Bear with me. We have x over 1/2, or x over 1. We can flip and multiply by the reciprocal. So we can also pull out a negative out of this top. So if I pull a negative out, I get the positive x to the 1/2 plus a y to the 1/2. And that's going to cancel out those negatives, isn't it? So we'll end up with x to the 1/2 plus y to the 1/2 divided by, when I flip this, I'm going to multiply by 1 over x. I can multiply x to the 1/2 and x by adding their exponents, and we get 2x to the 3/2. And that's going to be our final nice clean answer. And that gives you an idea of our second derivative. Some of them do become a little nastier than others. Some of them, like this one, a lot of work there, but it's something that we can all do. So good luck. If you have questions, ask. We're here to help.